Welcome back. Today we'll be understanding periodic table. Now what is it? See, we have already discussed about few of the elements, right? Where we can talk about hydrogen, oxygen and all those particular elements which we know whether they are metals, non-metals, metalloids. But if I want to arrange that in the sequence order and I want to understand about their properties, what all are metallic properties, what all are non-metallic properties, what is valency, we will be understanding each and everything using this particular topic, that is modern periodic table. First of all, before understanding what is this modern periodic table, we must understand what's periodic table, right? So when I talk about periodic table has certain elements, right? We will talk about the modern periodic table. We are aware of there are how many groups? There are 18 groups and 7 periods. Now you must be wondering, sir, what? Groups, periods, what are they? Just have a look. This is the modern periodic table. Fine. And as already understood, it is consisting of what? It consists of different elements, which includes hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. One second. What I said? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. This means I'm talking something in the sequence order. Modern periodic table is actually in the sequence order where we will talk about atomic numbers. But I told you, before understanding this modern periodic table, we must have an idea of periodic table where we are discussing about different elements. And if I'll go in the very starting where there was a logic that was given by the Daubernier, right? Triad's logic was given, then Newland's octave rule came up. There were several people who actually brought this table and told, okay, so these particular elements which are discovered can be kept in such manner so that we can easily understand about it. And yes, by seeing that periodic table, we can understand its nature. But as those particular researches were going on, then later on, in the present time that we are using is the modern periodic table, which looks like this. Now, please remember, earlier time, these particular elements were arranged in such a manner where atomic mass was taken into consideration. But here, atomic number is taken into the consideration. Very important. Mark my words, what I'm talking about atomic numbers. Please mark my words. Why? Because this question is asked again and again in the examinations. Now let's have a look at the definition. The properties of elements are periodic functions of their atomic numbers. That means they are arranged in such a manner where we are talking about the atomic numbers, where we can easily have the clarity what are metals, what are non-metals, what are metalloids. Now you must be wondering, sir, by seeing this? Yes, by just this particular periodic table, we can understand what all properties they are actually having. Now how we'll understand that? We'll be having a look at that one by one. So yes, again I'll say, if I talk about the modern periodic table's definition, so here the properties of the elements are periodic functions of their atomic numbers. Now this is important, it is asked in the examination many times. Now I was talking about something about groups and periods, right? So just have a look. 1, 2, 3 and so on till 18. So this is actually what? This is actually group, where I can talk about the vertical columns. Now if I talk about these rows, they are 7 in number. And yes, 1, 2, 3, 4, 5, 6, 7. These are what? These are actually known as periods. So in the examination it is asked, how many periods are there? So there are 7. How many groups are there? There are 18. Now one by one we will be understanding which particular group is known as what. For example, just for example's sake right now, this 18th group, this particular group is known as noble gas. That is, sorry, noble gases. That is, all these are the part of what? Here we talk about noble gases. Now why they are noble, what is that? I'll be telling you about it. So let's move forward now. So Henry Moseley was the one who has introduced the property of elements where we are talking about atomic number. Now, if I talk about this hydrogen, so here, if I'll see, here something is written. What? 1 here, right? So it actually represents what? See, there may be 2 numbers. Always there are 2 numbers which are mentioned here. The upper one is actually the mass number. Fine. What I'm saying? Mass number. Now, mass number you can relate, you know the word mass, where we are talking about amount of matter contained in a body. But basically, please remember, the number which is given above is what? That is mass number. I have a trick also so that we can understand it. Now the sequence out of which I was talking, hydrogen, helium, lithium, beryllium, boron, these are actually in the increment of the atomic numbers. Fine. So yes, if I talk about this particular part, so modern periodic table has actually adopted this concept of atomic number. Now, if I talk about what it consists of, so it is having 18 groups, where we were talking about 1, 2, 3, 4 and so on till 18, and 7 periods. So it is mentioned here, it consists of 18 groups and 7 periods. Group have the same number of valence electrons. Now what is it? What is valence electron? Just have a look. If I talk about first group, if I talk about the atomic number of hydrogen, that is 1, right? If I talk about lithium, then atomic number of lithium is what? 3. What is it? 3. In the similar manner, when I move forward, we must remember electronic configuration. We'll be having discussion on that as well. But at present, let me tell you, when we are actually making these shells, please remember, here it is given what? Atomic number. That is 1. So this means here, how many electrons are there? 1. If I talk about 3, so please remember all the elements are actually, if I'll just do the electronic configuration or I'll write the electronic configuration, it has the formula of 2n square. This means what? This first shell, this one, this is first shell, this is second shell and so on. So first shell is actually known as K shell, second shell is known as L, third one is M and so on. So it is using n square, where n would be what? N is actually the shell number. Now, if I talk about the first shell, if I'll put 1 here, so it would be what? 1's square. So it is going to give you what? 2. This means maximum 2 electrons can be put here. But if I talk about hydrogen, how many electrons are there? Just 1. So here we can say that in the outermost shell only 1 electron is there. Not talking about lithium. If I talk about lithium, I'll just try to put it 2 into 2's square, right? First one 2 into 1 square. So in the first shell, how many electrons can come? 2. Then in the second shell, how many electrons can come? 2 square is 4. 4 2s are 8. That is maximum 8 electrons can be put into the next shell. Now let's have a look. How many electrons are there? Just 3. In the first shell, how many electrons can come? Only 2. Right? What? Only 2. In the next shell, how many are left? 3 were there in total. 2 came in the first shell. So I'll draw here. 2 came in the first shell. So in the next shell, how many electrons? Just 1. So again you can see in the outermost shell, how many electrons are there? In the outermost shell, just 1 electron, right? So here, just have a look. In the outermost shell, again there is 1 electron. In this same manner, if I talk about sodium, potassium, rubidium, cesium, any of the element of the first group, you will be having only 1 electron in the outermost shell. That is actually known as valence electron. So this was as simple as that. That is, we are talking about the outermost shell. So number of electrons present in the outermost shell is known as valence electron. And whichever group it is, first group actually represents that it is having 1 electron in the outermost shell. Second, 2 electrons in the outermost shell. Third, 3 electrons in the outermost shell. Fourth, 4 electrons in the outermost shell and so on. So this actually gives us the clarity how many valence electrons will be there. Now what are valence electrons? Again I'll tell you. Valence electrons are the electrons which are present in the outermost shell. Fine. What were these shells? These shells which are represented by K, L, M, N and so on, where we have the formula of 2n square. Simple. Now this question of 2n square is asked in the examination. Fine. And yes, it is also asked about the valence electrons, number of valence electrons. If they'll talk about any of the group, you can directly tell. Fine. So it is actually classified into first A, then we have third A, third B, in so manner. Fine. And please remember, whatever element it is, it wants to complete its octet. That is, they in the outermost shell, they want their 8 electrons. That is octet. But in case of hydrogen and helium, we will say that they need to complete their duet. Fine. So let's continue with this part so that we'll go into detail in the further mode. Yes, moving forward to the next point. Number of shells increases down the group. So we were talking about shells, right? So here, if I talk about hydrogen, only 1 electron was there. If I talk about lithium, so we were talking about 3 atomic number, right? So it is 1 in the inner, 2 in the innermost, 1 in the outermost. So I'll draw it in this manner. So you can see that this was hydrogen, this was lithium. So number of shells are increasing. 1, then we have 2 and so on. So this means when we will go down the group, number of shells are going to increase. Fine. Each period marks a new electronic shell getting filled. So we are talking about electrons that are getting filled. How they are getting filled? Using that formula. Remember 2n square? So yes, when we'll move downwards, the number of shells are increasing. Fine. Let's move forward now. Elements are arranged in the increasing order of their atomic numbers. We have already understood that. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. That is, atomic numbers are increasing there, right? So yes, 18 vertical columns are there which are known as groups. We have understood that. That is from right to left. If I'll go, we can take out. We can discuss about this. That is hydrogen. Then we have this group, this group, this group, and so on. These are 18 groups. So 18 vertical columns are there which are known as groups. That is, I'm talking from right to left. Fine. So yes, moving forward now. Now you must be confused, sir. This one is your right hand, but it is left. Why? Because I'll say that if I'll stand like this, now what is going to happen? This is my left hand. So left to right, right? So yes, since I'm standing in this manner, so it is getting opposite. So again, I'm saying from left to right. Okay, let's move forward now. First group, that is, we are talking about this hydrogen, lithium, sodium, potassium. How you will remember that? So is there any trick? Yes, it is there. You can remember it by Halina ki rab se faryad. What is that? Halina ki rab se faryad. So you can create any of your trick by your own. Fine. In order to understand the sequence order. So whenever a question is asked in the examination, you can directly take it. So Halina ki rab se faryad. That is hydrogen, lithium, sodium. Then we have potassium, rubidium. Then we have cesium, francium. So if I go with the sequence order, so I'll say that this is actually what? These are alkali metals and they form strong alkalis with the water. That's why they are alkali metals. Talking about second group, that is beryllium, magnesium and all. So is there any concept? Yes. Please remember, in Hindi I'll say, beta mange car scooter, baap razi. Beta, beryllium, mange, magnesium, car, calcium. So you'll go in that sequence order. It is for the second group. Yes. So second group is actually known as alkaline earth metals. They form weaker alkalis as compared to group 1. So if I'll compare with the group 1, hydrogen, lithium, sodium, in comparison to that, they are making weaker alkalis. Fine. So they are actually known as alkaline earth metals. So group 2 is known as alkaline earth metals. This is asked in the examination. Which are alkali metals? Which are alkaline earth metals? So you must remember. Next, moving forward. Talking about group 3, 4, 5, 6, 7, 8, 9 and till 12. This part. 3 to 12. This part. Here we call them as a transition elements and two outermost shells remain incomplete. Now what's that incomplete? We remember we were talking about the completion, right? Where we can talk about octet, duet. So if I'll talk about the outermost shells, so two outermost shells remains incomplete in this particular groups. That is from 3 to 12. Now if I'll talk about group 13, this is boron family. Why is it so? Because the first element which is present in this particular group is what? This is boron. That's why it is known as boron family. If I'll go with the 14th, carbon is the first element. So it is known as carbon family. Then nitrogen family, oxygen family, and so on. So yes, let's have a look one by one. So when I talk about group 13, it is known as boron family, since boron is the first member of the group. In the similar manner, carbon is the first member of the group. So carbon family. Group 15, nitrogen. That is nitrogen family. Simple. Yeah. Moving forward. Now talking about group 16. If I talk about group 16, here we have oxygen. Obviously, oxygen family. So yes, oxygen family, and these are also known as chalcogens. Now these chalcogens are important. Please remember, in the examination it is asked which particular group. So you can directly say, sir, it would be oxygen group. Fine. So yes, they are ore forming. Then talking about group 17, they form salts. Where we'll say that they are halogens. In the examination they are asked which particular group are known as halogens. So please remember the group, which one? 17th group is actually halogens. Fine. Why? Because they are actually salt forming. Okay. So they are actually salt forming. That's why they are known as halogens. And this one is important. Very important. Please remember that. Fine. Okay. Next. Let's talk about 18th group. I was telling something about it in the starting itself. What? They are noble gases. If I talk about them, they are noble gases, and this 18th group is also known as zero group. Now, noble gases, inert gases, one and the same thing. Very, very important thing is that they neither share their electrons, neither they want electrons, because their outermost shell is complete. That means if I talk about helium, duet, others, we'll talk about their outermost shell with the octet. That is, in short, I'll say that their outermost shell is complete. That is, they don't want any kind of bonding. Neither they share electron nor they take electrons. Fine. So yes, outermost orbit is completely filled. So they need not require any kind of bonding. Neither they want to donate electron, neither they want to take electrons. But if I talk about others, they either donate electrons or take electrons. Now, what does this mean? This will give you the idea of metals and non-metals. How? I'll tell you about that. Let's wait for a while. Okay. Now, if I talk about the arrangement of elements in 7 periods, that is, if I talk about the first period, there are only 2 elements, that is hydrogen and helium, right? So yes, first period, only 2 elements are there, that is hydrogen and helium. It is a very short period with just 2 elements. If I'll move forward, second period, it consists of 8 elements, that is lithium to neon. Just have a look. Lithium, beryllium, then we have boron, carbon, nitrogen, oxygen, fluorine, neon. So this is the second group, right? Now this is actually short period. If I talk about third period, then here again we have 8 elements, right? Just have a look. Third period, 1, 2, 3, 4, 5, 6, 7, 8, right? So this is the third period. Now if I talk about the fourth period, we have total 18 elements here. So this number is actually asked in the examination. Do not forget. Fourth period with the 18 elements. Now just try to count it. 1, 2, 3 and so on. Because we know that 18 groups are there. So we can say that these are having 18 electrons. Sorry, 18 elements. Now you must be wondering, sir, 18 elements? This means 4, 5, 6, 7 all must be having 18 elements? No. Why is that so? Just have a look. Again, if I talk about fifth period, 18 elements are there again. So yes, that's true. But if I'll go with the 6th and 7th, please do not get confused. This lanthanum series and actinide series, lanthanide series and actinide series, they are present where? So this lanthanide series will present in the 6th period. Fine. If I talk about the 7th period, we have actinide series. So yes, we have this series which is present here, and hence this will be the longest period. Let's have a look. If I talk about 6th period, so 6th period consists of 32 elements. 6th period is having the 32 elements. Very important. It is asked in the examination, which is the longest period with the 32 elements. 6th period. If I talk about 7th period, here we have 28 elements here. And yes, please remember, if I'm talking about the 32 elements, they are present where? In the 6th period. Okay. Let's move forward now. Now you must be wondering, sir, can we remember it also? Yes. You can create your own trick. For example, if I'll go with this lanthanide series, you can have a look. लाख सोचा पर न थी प्रेम की सीमा यूं गधे ने तब ड्राई क्लीन होकर तुम्हें लव यू लिखा. So you can create any kind of trick whichever suits you. The important thing is we must remember the sequence order, which is very important for the examination. Fine. So it can be any kind of trick. For example, हलीना की रब से फरियाद, बेटा मांगे कार स्कूटर, बाप राजी, लाख सोचा पर न थी प्रेम की सीमा यूं गधे ने तब ड्राई क्लीन होकर तुम्हें love you likha. So you can create any kind of trick so that you can remember the sequence orders, so that whenever it is asked in the examination, which they'll give you 4 options, they'll ask which is having the more number of shells. You can just have a look. If I'll go from up to down, number of shells are going to increase, right? So in this manner, if someone is asking me from the any of the elements, they'll take 4 options and they'll ask which one is going to have 1 valence electron, or what would be the valency. I'll be telling you about the valency as well. So you can just directly have a look at the group and directly give the answer. So if you will be remembering this particular tricks and this table is in your mind, you can do anything. Okay, let's move forward now. Let's go with the next part. So yeah, 14 elements, 6th and 7th periods are placed separately at the bottom of the table. We have seen that, right? So this is actually placed separately at the bottom of the table because we cannot put over here. So this was lanthanide series and this was actinide series from 6th and 7th period. Okay, so let's move forward now. 18 groups of elements are divided into 9 main groups, that is 1, 2, 3, 4, 5, 6, 7, 8 and 0. Now I was talking about first A, right? Then third A, third B, right? So this is actually applicable here. Now, group 1 to 7 have 2 subgroups, A subgroup, B subgroup. So group 8 has 3 rows of elements, group 0 has 1 row of elements. Here, if I talk about A subgroup, so A subgroup elements are called normal elements. B subgroup are called transition elements. Now if I talk about lanthanide and actinides, they are called inner transition elements, where we have group 1A, group 2A. That is 1A, second A. Remember? So yes, 1A elements are called alkali metals, 2A elements are called alkaline earth metals. Remember that part where I was talking about Halina ki Rabse Faryat? What was it? Alkali metals. If I talk about beta mange car scooter baap razi, that is beryllium, calcium. They all were what? They were in the group 2, or we can talk about second A. Then talking about 7A. So if I talk about 7A, these are the elements which are known as halogens. Remember, if I talk about this, what is that? It is actually part of 17th group, or we can say 7A. Then talk about group 18, zero group. They are called as noble gases. Remember what was there? Helium. Then we can talk about argon, krypton. These are what? These are actually noble gases where their outermost shell is already complete. They need not do any kind of bonding and all. Okay. So elements having the same number of valence electrons. So here we can talk about group 1. They have 1 valence electron. Group 2, they have 2 valence electron. Group 3, they have 3 valence electron, and so on. Remember? First group we are talking about hydrogen, lithium, sodium. 1 electron in the outermost shell. Now, moving forward, in a period, all the elements contain the, they will actually have the same number of what? Same number of valence electrons. In every group, they are going to have the same number of valence electrons. That is, in the outermost shell, they will be having same number of electrons. Okay. Sorry, valence electrons. Fine. Okay. Next. Let's talk about valence electrons now. We have already seen the clarity. Now let's have a look at this figure also. In a period, number of valence electrons increases from 1 to 8 from left to right. See, first group, second group, third group, fourth group. I already told you, when you will be moving with these groups, first group will be having 1 valence electron. In second group, we will be having 2 valence electrons. That is, what are valence electrons? These are the electrons which are present in the outermost shell, right? So yes, just have a look. These are the shells. This is the nucleus actually in the center. Then we have these shells. If I talk about the outermost shell is actually having the electrons which are known as valence electrons. Simple. So if I talk about the number of shells, they actually remain same. We are talking about a period. Fine. So in a period, we are going to have the same number of shells. But yes, number of valence electrons are going to increase as we are moving from left to right. Again, I am saying left to right. That is starting from hydrogen going till helium. So 1 till 18. We are talking about period here. If I'll go with the period, first period, second period, third period, and so on. So here, please remember, number of shells are going to be same. But when we are moving from left to right, the number of electrons, valence electrons are going to, what will happen? The number of valence electron will be increasing. For example, if I'll write hydrogen, helium, lithium, beryllium, and so on. So if I'll talk about lithium, so here I'll be having 1 valence electron. If I'll talk about beryllium, so I'll be having 2 valence electron. Why? Because it is there in the second group. As simple as that. Okay. So here we have discussed about it. Moving forward. If I talk about group, that means I'm talking in this manner. First, second, third, and so on till 18. So here number of valence electrons is the same for all the elements, right? We have taken the example. What they are saying? If I talk about hydrogen, lithium, then sodium, then potassium. If I'll go in the same group, the number of valence electrons are going to be same. Just have a look. Number of valence electrons is same for all the elements. Number of shells increases from top to bottom. We have understood this. Number of shells will actually increase when I'll go from top to bottom. Simple. Okay. So now talking about the valency. What's valency? See, we understood about the valence electrons, right? When we talk about the valence electrons, we will be able to understand what I was saying. All of these elements which are present here, they actually want their outermost shell to be complete. Now, if we'll talk about hydrogen, helium and all, they want that in their outermost shell only 2 electrons can be there. That is, their duet must be complete. From name itself it is clear, duet. Other elements actually want what? That their outermost shall be complete. Now, we can take example of any of other element. We can talk about, let's say, what? Carbon, for example. For their outermost shell to be complete, they need what? They need 8 electrons. That is octet in their outermost shell. So for that, what happens? They will either give electrons or they'll get electrons. This we'll understand in the next session where we'll be understanding about the chemical bonding. But right now, please try to understand if there is only 1 electron in the outermost shell and we have already 8 electrons. For example, if I'll write the configuration in this manner, 2, 8, 1. Now, what is easier for them? To take 7 electrons or to give 1 electron? Obviously, to give 1 electron would be easier, na? So yes, here we are talking about the first group. those elements which can easily donate the electron are known as what? There will be actually metals. They are actually metals who are easily donating the electrons. And the ones who are taking the electrons are non-metals. So this will be the case of sodium. This is the electronic configuration for this. Now I'll write for chlorine. It would be 287. Just have a look. For it, it's easier to gain one electron. And it's easier for sodium to donate one electron. In this manner, what will happen? There would be a bonding, right? Where one electron is given to the chlorine, and chlorine is now having configuration what? 288. Just after taking this electron, and sodium is having what? After giving the electron, it will be having this configuration. This means sodium is also happy with it, and chlorine is also happy with it. But chlorine has taken the electron. Taken the electron, that means negative. Given the electron, that means positive. And here, what will happen? If I talk about the bonding, this will give you NaCl. Yeah, the salt that you are eating, right? So yes, I was talking about valence electrons. Valence electrons, outermost shell, remember? So these are the outermost shell electrons. So if I talk about sodium, valence electron is 1. Chlorine, outermost shell, valence electrons, 7. What I was saying, it will donate electron, 1 electron, it will be having electronic configuration, its outermost shell will be filled. After gaining it, its outermost shall be filled, both will be happy. So this is the thing. Now, how many electrons can be donated or can be taken gives you the valency. There's a difference between valence electrons and valency. Valency is how many electrons I can take in order to complete my outermost shell. Either I can take or can give. This will give me valency. But how many electrons are there in the outermost shell? That will be valence electrons. Simple. Let's have a look. So the valency of the elements in a period, it increases from 1 to 4. That is, if I talk about hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So we'll go here. 1, 2, 3, 4, 5, 6, 7 and this 8. Right? So if I'll go in this manner, so I know that in the outermost shell there are 1 electron in this first group. That is 1 electron, this is the valence electron. Here 2 electrons, valence electrons, 3 electrons, 3 valence electrons, 4 valence electrons, 5 valence electrons and so on. Now, if I'll go till 4th, now this will create what? They will actually do what? Now bonding is required, right? So from here to here, we can say that here we have metals, but these are non-metals because they are actually gaining the electrons. The one who is giving the electron is metal. The one who is taking the electron is non-metal. Simple. Okay. So if I'll go from after 4, we'll be having these particular part where they are taking the electrons. That is, it requires 3 electrons. So its valency is 3. It requires 2 electrons for the bonding. So 2. That is outermost shell should be completed, right? If I talk about this 7th group, they just require 1 electron. So if I talk about 7th group, number of valence electrons are 7. But valency is 1. Because after taking only 1 electron, their outermost shell will be filled. So for completing the outermost shell, either by giving or taking, how many electrons can be taken or given? That will give you valency. Simple. Fine. Okay. So here, first it will increase till 4. Then it will decrease from 4 to 0. So from left to right. Okay. So valency we have understood now. Let's move forward. Okay. Now talking about period, if I talk about the atomic size, we don't know that number of shells are going to increase, right? So if number of shells will increase, then this atomic size will also increase now. From top to bottom, less size, more size, more size. So if I'll go from top to bottom, atomic size is going to increase, right? Top to bottom, atomic size will increase. That's what it is written. Atomic size decreases from left to right. That is, from left to right, atomic size will decrease. But from top to bottom, atomic size will increase. So yes, let's have a look. Atomic size decreases from left to right. Nuclear charge increases. Electrons are pulled closer to the nucleus. Now, why this atomic size is actually decreasing? There's a reason behind it. If I talk about this, here what is happening? This because of the presence of this nuclear charge. We know that opposite charges attract each other, right? So they will do what? They tend to actually attract the electron. Because of this, from left to right, the number, if I'll talk about the atomic size, that is actually decreasing. But from top to bottom, it actually increases. There's a logic behind it. Okay, so electrons are pulled towards the nucleus. We have understood that. So from left to right, atomic size will decrease. But if I go from top to bottom, atomic size will increase. Let's have a look. So if I talk about the distance between the center of the nucleus of an atom and its outermost shell, or half of the internuclear distance between the combined atoms in a molecule. So atomic size of element increases from top to bottom. We have understood that? Now, number of shells increases, and here we have understood, again I'll say, from left to right, atomic size is decreasing. Why? Because nucleus is actually attracting those outermost electrons, right? So yes, not only outermost, others also, but there's a distance between that nucleus and outermost electron that is actually giving you atomic size, right? So yes, from left to right, the size is decreasing. From top to bottom, that size is increasing because number of shells are increasing. Simple. Okay then, moving forward. So the smallest element in terms of radius is helium. Now this is very important question. It may be asked in the examination. If someone asks you the smallest element in terms of radius, that would be helium. And the largest element in terms of radium would be, sorry, in terms of radius will be cesium. Fine. Okay. And helium is present here. Next. So atomic size depends on the number of shells and the nuclear charge. An increase in the nuclear charge decreases the size of atom. Again, I'll say the same thing. Just have a look. Now there are electrons which are present here. Now it is actually trying to attract electron towards itself. Opposite charge attracts each other. So when we are talking about left to right, atomic size decreases. Why? Because here this particular affinity, or I'll talk about nuclear charge. So this nuclear charge is doing what? Here it is attracting the electron. So because of this attraction, the size is actually decreasing. Okay. So an increase in the nuclear charge decreases the size of the atom. Next, what is metallic property? We have understood. If I talk about metals, they are ones who can easily donate the electron, right? So just have a look. If I talk about a metal, where we are talking about sodium. What is the atomic number of sodium? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is in the increasing order of their atomic numbers. So if I'll count hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. In this manner, when I'll go to the sodium, it is present on the 11th number. So its atomic number is 11. If I'll go with the chlorine, it is with the 17. Now we have already understood the sequence order. Remember, I was talking about 2n square. So if I try to put the number of electrons, so in the first shell, there would be 2 electrons. In the second shell, there would be 8 electrons. And in the outermost shell, there will be 1 electron. Remember that formula, 2n square. So yes, innermost 2, then 8, then 1. So outermost shell is having 1 electron. This means here, number of valence electron is what? 1. Totally correct. If I talk about this, a chlorine, just have a look, 17. That is 2, 8, 7. Became 17. Total 17 electrons. Now, just try to have a look. These 7 and this 1. Sodium wants to complete its outermost shell. Chlorine also wants to complete its outermost shell. What can happen? We can easily donate this 1 to this 1. That means here metal, that is your, element, that is a sodium, will be having 2, 8 electronic configuration. That is outermost shell is filled with 8 electrons. And here it will be 2, 8, 8. Just have a look. Here 2, 1, 2. Then if I go with the second shell, 1, 2, 3, 4, 5, 6, 7, 8, 2, 8. And 1 is there in the outermost shell. Now what will happen? This 1 electron will be given here. Because of which outermost shell will be having 8 electrons. Now what I have told? The one who gives is metal. The one who takes is non-metal. Simple. So yes, there would be bonding between two. And in this manner, we can say that the one who is giving electron is metal, another one is non-metal. And it's always there where first of all metal comes, then comes the non-metal whenever we talk about any of the formula. For example, if I'm talking about a salt, sodium chloride, the same salt you're using in your food every day. Sodium chloride, NaCl. Na has given the electron positive charge. Chlorine has taken the electron negative charge. So whenever we write the formula, first of all we'll be writing metal, then we'll be writing non-metal. It's always there. Always. Fine. Okay, let's move forward. In a period, metallic property of the element decreases left to right. Why? When I'll try to move from left to right, I know that here easily electron could be given in the first group. Why? In the outermost shell only 1 electron was there. Easily can be given. Then came 2. Right? So here the tendency of is lesser. But yes, they are also metal. They are giving 2 electrons easily. Then 3 and so on. So if I'll go from left to right, this metallic property will decrease. Right? Okay. So here what I'm saying, the metallic property of the elements decreases. So if I talk about the metallic character, elements lose their valence electrons in the outermost orbit and they form a positive ion and are considered as metals. Simple. The thing we have explained from the metal part here, the same logic which I have explained for the non-metal is going to come. That is non-metallic property. If I talk about this metallic property in a group, the metallic property of the elements increases from top to bottom. Why? There's a reason behind it. If I talk about these shells, just have a look. The number of shells are increasing, right? If the number of shells are increasing, the electrons and this nuclear distance is actually also increasing. Now this means there is less force of attraction. When there is less force of attraction, these electrons can easily be taken out. You can talk about long distance relationships. Fine. One is where you are in your college time, you're with your girlfriend or you are with your boyfriend, where we are near to each other. If someone comes, hey, I have a boyfriend, hey, I have a girlfriend, don't try on me. But if I talk about long distance relationships, one is Shimla, one is in Kanyakumari. Fine. Just an example. Just try to relate it with that. Okay. So distance is more. Easily electron can be taken out. Right? So yes, if I'll go from top to bottom, in the bottom part, it can be easily taken. That is, metallic property will increase from top to bottom. And it would be opposite where it would be happening from left to right, right? So yes, just have a look. In a group, metallic property of the element increases from top to bottom. Understood? Distance. So let's take an example. If I go with the third period elements, so we have metals, that is sodium, magnesium, aluminium. Now, please remember, if we are talking about the metalloids, please remember, these are the metalloids where we are having the property of both, that is metals and non-metals. Fine. We can talk about silicon, germanium, we are aware of that, right? So silicon, what? So you can talk about metalloid over here. Then talking about non-metals, so you can talk about chlorine and all. We have already taken this example, non-metal, right? So yeah, moving forward with this non-metallic part, if I talk about this non-metals, so these elements that have the tendency to gain the electrons or attain octet in their outermost shell. I'm talking about what? I'm talking about the octet. Again, I'll say about their completion of the what we'll say here, completion of their octet is there. Actually, octet is completed. That is number of electrons which are required in the outermost shell. That would be what? 8, right? But in some of the cases, we were talking about 2 as well. That means they need to complete their outermost shell. Yes, so non-metals, elements have tendency to gain electrons or attain octet in their outermost shell. Non-metals have 5, 6 or 7 electrons in their outermost shell. That is, it will be requiring 3, it will be requiring 2 and it will be requiring 1. Where this can be the example of chlorine, where it needs only 1 electron to complete its octet, right? Okay then, let's move forward. So non-metallic character if I talk about, so it depends on the nuclear charge. Greater the nuclear charge, more tendency to gain the electron. More charge, more easily it can gain the electron. So more is the metallic character. If I talk about the atomic size, greater the nuclear pull, greater the tendency to gain the electron, greater the non-metallic character. Okay. So here, let's move forward. Non-metallic property of the element increases from left to right. But if I talk about the metallic property, it was increasing from top to bottom. There's a difference between two. So we'll talk about this third period elements we have already discussed, right? What are metals, what are non-metals, what are metalloids. So these were the important things, fine? So now in the next class, we'll be understanding about the chemical bonding. So what we studied today, we understood about the periodic table, right? Modern periodic table where we were having 18 groups and 7 periods. If I talk about the starting groups, that is, we can talk about first group. There was valence, 1 electron. Then second group, 2 valence electrons and so on. So in the starting part, we were having metals. Why? Because they were easily donating the electrons. In the later part, that is from left to right when we were going. So in the right part, what was there? In the right part, here they were actually attaining the electron. So the one who is gaining the electron is what? They are actually non-metals. And whenever we are talking about metals and non-metals combination, we are talking about formula, right? We were discussing about NaCl. So first of all, that metals part is going to come with that positive charge. Then non-metal part will come with it negative charge. Remember? So if you have any kind of doubt, comment section is there. Please let me know. I'll help you out. And in the next session, we'll be understanding about the chemical bonding. Okay? So thank you for being such a wonderful audience. And yes, do not forget to subscribe our channel. Okay,